In lecture 3, mainly we will discuss the following problems. Okay, these are the very basic signals, and we will find the transform of Laplace transform of the following signals. First, we will take the signal x of t is equal to e raised to at into u of t. Okay, and in order to find the Laplace transform, this is the basic equation. X of s is equal to integral minus infinity to infinity x of t e raised to minus st dt. So in place of x of t, here it is given e raised to at into u of t. So we'll see how we can solve this particular problem. So here the integration is from minus infinity to infinity. In place of the signal, you can write e raised to at into u of t, and remaining as e raised to minus st dt. And we know that the signal u of t is equal to 1 for t greater than 0 and 0 for t less than 0. So this will be like this, the waveform. Graphically you can represent 0 in time axis, the function value is 1. When the t value is greater than 0, the function magnitude is 1. So we can we can simplify this integration, or we can start the integration from 0 onwards, 0 to infinity, and we can group, it becomes e raised to minus s minus a into t into dt. Okay, we are grouping these exponential terms. Now we can integrate this, so it becomes e raised to minus s minus a into t divided by s minus a. So minus also. Now we need to apply the limit. It's from 0 to infinity. So if you apply the limit, t is tending to infinity, there will be two cases. So e raised to minus s minus a, and assume that this s minus a is greater than 0, or it is positive. Okay, or very specifically you can write real part of s minus a is greater than 0. So that quantity is positive, and if you apply the limit to infinity, and finally you will get e raised to minus infinity, which is equal to 0. And this is case 1, and we'll take another case, that real part of s minus a less than 0. This is case 2. So if you apply that limit, you will get e raised to minus, and this s minus a is also negative, and you need to apply limit infinity. So you will get e raised to infinity, which is approximately infinity. So there are two cases. We will prefer the first case because we are getting a converging answer. So this integration becomes, you can apply the limit, so e raised to minus s minus a into t, when t is tending to infinity, you can apply the result 0, and when you apply the limit 0, it becomes e raised to 0. Okay, and remaining minus s minus a. So after simplification you will get s minus a, and there is one more condition, that is known as the ROC. Okay, real part of s minus a greater than 0, or we can say sigma minus a greater than 0, or we can write sigma greater than minus a. Or in other words, we can say the real part of s minus a means s is equal to sigma plus j omega. So if you substitute real part of sigma plus j omega minus a, okay, it's greater than 0. Sorry, I made a mistake. It becomes plus a. Okay, and if you take the real part, it becomes sigma minus a. Sigma minus a greater than 0. That is written here. Okay, if you want to know more about this, please watch the previous lectures. Okay, so we got the ROC and sigma greater than a. So here it is given that a is positive. Okay, so if you take the graph, here you can mark a on the positive side, and sigma is equal to a means it's a straight line parallel to g omega s, and sigma is greater than a means towards right. Okay, so this is the ROC. So the answer is 1 by s minus a. Okay, now we'll see how we can solve this problem by comparing the previous result. Okay, in the lecture 2 already we discussed another question, that is e raised to minus 80 into u of t. This is a standard form, and the answer is 1 by s plus c. And the ROC, either you can say that real part of s greater than minus a or sigma greater than minus a. Here you can see that is e raised to minus a. If it is e raised to minus a, it becomes s plus a, and the ROC is sigma greater than minus a. If it is minus, here it is minus. If it is minus, here it is positive. But in this question, it's given e raised to 80 into u of t. So you can see the difference. So you need to write the answer. Here it is a is positive, so here a is negative. So we need to write like this, it's s minus a. Okay, and ROC, either we can write real part of s greater than a, because here it is minus a, then it's minus. Now here it is positive, so we need to write positive here. Or you can write sigma greater than a. So ROC will be same. Here given a is positive, so you can mark a in the positive side, and this is a line parallel to j omega, or sigma is equal to a. So this line indicates sigma is equal to a, and the ROC is greater than sigma is equal to a, so towards right. So this is the ROC. So this region, actually shaded region, indicating the ROC. Now we will discuss next question. Again, it's a slightly modified version. E raised to minus e raised to 80 into u of minus t. Okay, now we'll see how we can solve this problem in direct way. So integration is from minus infinity to infinity. Already there is a minus, you can take this minus outside. Minus e raised to 80 into u of minus t into e raised to minus st dt. Okay, now there is a non-signal, that is u of minus t. U of minus t is equal to 1 for minus t greater than 0, or you can write t less than 0, and you can write 0 for minus t greater than 0 or t greater than 0. Okay, so graphically you can represent the reversal form of u of t, time reversal form of u of t, that is u of minus t, which exists or is having non-zero value from minus infinity to 0. So your integration becomes integral minus infinity to 0, and you can group the terms minus s minus a into t dt, and already there is a minus, and you can integrate this. So you will get e raised to minus s minus a into t divided by minus s minus a, and the limit is from 0 to minus infinity to 0. And now we need to apply the limit for the signal e raised to minus s minus a into t, and limit t is tending to minus infinity, not infinity. So we will take the first case, the real part of s minus a is greater than 0. So s minus a is greater than 0 means it becomes positive. So we can write e raised to minus, then positive, and the limit is minus infinity. So you can see that it becomes e raised to infinity, which is equal to infinity. This is case 1. And another case, when real part of s minus a is less than 0, means it's negative. So we can write e raised to minus negative, and the limit is minus infinity. So after simplification you will get it becomes e raised to minus infinity. E raised to minus infinity is e raised to infinity, which is equal to 1 by infinity, which is approximately 0. So we'll prefer the second option because we are getting a converging answer 0 when t is tending to minus infinity. So we can continue the integration we can apply the limit like this. When you apply the limit 0 first, okay, you will get 0 here, then when you apply the limit 0 it becomes e raised to 0, and when you apply the limit t is equal to minus infinity, you will choose the answer 0 here, then divide by minus s minus a, okay, and after simplification you will get it becomes 1 by s minus a, but the ROC part you need to write the condition s minus a less than 0, or real part of s minus a less than 0, or s is equal to sigma plus j omega minus a. So the real part of this quantity should be less than 0, or you can write sigma minus a less than 0, or in other words sigma less than a. So we can plot the ROC in the S plane. Again it is given that a is positive, so again I will mark a here, and this is the line sigma is equal to a, sigma is equal to a line, but here it is given it's less than a, okay, ROC means towards left. So this is the ROC. So S plane, j omega axis and sigma. So we can compare these two questions. The previous also the answer is again 1 by s minus a, but the ROC is different, okay. I'll quickly explain that. And the previous case, as a causal form, the answer is 1 by s minus a, but sigma greater than a. Now we can see that again the answer is 1 by s minus a, but sigma less than a. Here the signal is in an anti-causal form, okay. This is the anti-causal form. Again the same problem you can apply by using the previous result which we discussed in lecture 2. So if there is an anti-causal signal in this form, this is the standard form we will use in the lectures, minus e raised to minus 80 into u of minus t. But here the question is slightly different, minus e raised to not minus 80, it's 80 into u of minus t. So you can write the result. Here is a minus, so here also minus, and here it is minus a, but here it is a. So if it is minus a, you need to write plus a here, and here also minus a. So we need to change here, so it becomes 1 by s minus a, okay, and ROC you can write real part of s less than a, because here it is minus a, it's minus, now it is a, so you need to write a, or you can write sigma less than a. So ROC will be like this. This is sigma axis and this is j omega, and sigma a is positive, so in the question it is given, and it is less than a means towards left, okay. This is ROC. Either we can use this result and or directly you can apply. So next we will discuss another question. Again this is slightly there's a small difference from the question. Is again e raised to 80 into u of minus t, okay. U of minus t means is an anti-causal signal, a signal which exists in the negative side, because it is u of minus t. The presence of u of minus t indicates that the signal is an anti-causal signal. If anti-causal signal, we can use the result by applying this result. We can solve this, okay. So if you write the question here and if you compare, you can see that it's e raised to 80 into u of minus t, okay. Again the given question is also in anti-causal form, so we can use this result, but here you can see that there is no minus in our question. so definitely there will be a minus in the result, and here it is minus a, but here it is a plus a. So we can do the changes. So we need a minus here to compensate this minus. So and where is minus a, now it is plus a, and the ROC is sigma less than a. Okay, and this will be the ROC, sigma 90 causal signal. So ROC will be left of the pole. So this is the ROC, and this is S plane. Okay. Next we will do another question. It's a combination of two signals, e raised to 18 into u of t. So if you apply the limit or if you substitute the question here, it's integral minus infinity to infinity e raised to 80 into u of t minus e raised to bt into u of minus t. Okay, this is signal x of t. So now we got x of t and e raised to minus st dt, and we can split the integration. It becomes integral minus infinity to infinity e raised to 80 into u of t into e raised to minus st dt. Can split the integration. So again integral minus infinity to infinity e raised to bt into u of minus t into e raised to minus st dt. Okay, so if you compare with the previous question, so this is a causal signal. We already got the result, so we can call it as x1 of t, and this is another signal which is an anti-causal signal. I can call it as an x2 of t. Okay, we can consider these two signals separately. So x1 of t or the Laplace transform of the signal. So this is a signal I mentioned as x1 of t, and this is a signal I mentioned as x2 of t. So x1 of the Laplace transform of x1 of t can be written as like this by using the result. Okay, if you use the result, you can write x1 of s. Okay, here it is e raised to 18 to u of t. So after simplification you will get 1 by s minus a, and ROC is sigma greater than a. Okay, and the second signal which is x2 of s can be written as 1 by again it's an anti-causal signal, so we can use this result. So it becomes s minus, here in place of a it is given b, so s minus b and sigma less than b. Okay, either you can simplify this integration by expanding writing the definition of u of t and u of t. That was already done in the previous question, so we need to repeat that, and finally you will get this answer. x1 of s is 1 by s minus a and sigma greater than a, another one is sigma less than b. So now we need to find is there any common area for this particular one signal exists when sigma greater than a, and another signal exists when sigma less than b. And actually we need to find the Laplace transform of the sum of these two signals. So we need to check whether there is a common area for this signal. For example, a and b are positive, so I can mark a and b, and this is sigma is equal to a line, and this is sigma is equal to b line. And the first case, sigma greater than a. Sigma greater than a means towards right. Okay, right of this particular line, and sigma less than b means left of this particular line. And one signal exists less than b and another signal exists greater than a. So it's like this, less than b and another one greater than a. So there is a common area, okay, which exists from a to b. So both signal exist from a to b. So we can conclude the Laplace transform, the combination of these two signal exists. So I can write like this. Laplace transform of individual signal is 1 by s minus a plus 1 by s minus b, and the ROC should be between a and b, that is a sigma less than b. Okay, and I can plot this ROC like this. If a is here and b is here, and this is the line which passes through a, and this is b, and greater than a, between a and b, so this is the shaded portion. Okay, the Laplace transform of the signal exists in this particular region. And one more point, we don't know whether a is greater than b or b is greater than a, like that. So here we'll assume that b is greater than a, and we'll consider other case also when a is greater than b. So when a is greater than b, there is a problem. So a is higher, so a is here and b is lower than it. So this is sigma and this is j omega axis, and in first case sigma greater than a, sigma greater than a means towards right. Okay, and second case less than b, second signal sigma less than b. So if you observe this particular ROC, there is no common area, so no common ROC, so x of s does not exist. It's very important, you always need to check the ROC portion. So in this question, if a is greater than b, there is no Laplace transform, but for if b is greater than a, then there is a Laplace transform, and thus Laplace transform exists only in this particular region when the sigma values a between a and b. Okay, now we'll do another problem. Again it's a combination of two signals, so I can substitute here integral minus infinity to infinity 3 e raised to minus 2t into u of t minus 2 e raised to minus t into u of t. So this is a signal, okay, and to e raised to minus st dt. Okay, so now we can split the integration. This integration is from minus 3 is a constant, and e raised to minus 2t into u of t into e raised to minus st dt minus 2 into integral minus infinity to infinity e raised to minus t u of t into e raised to minus st dt. Okay, so after simplification, just like the previous case, we can solve this. So this becomes integral 0 to infinity e raised to minus s plus 2 into t dt, okay, minus 2 integral 0 to infinity e raised to minus s plus 1 into t. Now we need to apply the limit, and after applying the limit, you will get one part like this, 3 into 1 by s plus 2, and the ROC of this particular portion is sigma greater than minus 2. Okay, and the second part you will get minus 2 into 1 by s plus 1, and ROC of this particular portion is sigma greater than minus 1. Okay, so we will get two signal, and we need to verify the ROC. Okay, is there any ROC exists? And here you can see one signal is minus 2 and another one is minus 1, and you can see that it's greater, one signal is sigma greater than minus 2 and another one is sigma greater than minus 1. So I can conclude like this: sigma, one signal is sigma greater than minus 2 and another one is sigma greater than minus 1. So the right of sigma is equal to, so one signal is greater than minus 2 and another signal is sigma greater than minus. So I can see that the combination, or as a common area, which is sigma greater than minus 1. So I can write x of s exists and in this common area. So 3 into s minus 2 minus 2 into s plus 2 and s plus 1, and ROC is sigma greater than minus 1. So you can plot this ROC like this. This is sigma axis, this is j omega, and the poles, one at minus 1, other one is minus 2, and it's greater than minus 1. So that is ROC of the signal. I can also simplify this, 3 into s plus 1 minus 2 into s plus 2 divided by s plus 2 into s plus 1. Okay, so after simplification it becomes 3s plus 3 minus 2s minus 4 divided by s plus 2 into s plus 1. Okay, and if you simplify this, it becomes s minus 1, s plus 2 into s plus 1, and here you can see that one more 0 is there. If you equate the numerator, that exists when s is equal to 1, that's a 0. So here at the point 1 you can mark a 0, okay, at the two poles, and this is the ROC, sigma greater than minus 1. So that is the ROC. Thank you.